Welcome to the third lesson of Chapter 6. So in this lesson, we're going to actually look at a data set to see if it comes from a normally distributed population. So we're going to be using a few tests to determine normality. So the goal is to be able to use these tests to see if any distribution that I give you is normally distributed. So the first thing that you want to know is that there are many tests that can be used to determine if something is normally distributed. So it's essential to check the data to see if the data actually comes from a normal population. So this should say normally distributed, or approximately so. So there are several ways to check for this normality. The easiest way is to actually draw a histogram, which is something that we've already done in the course quite a few times actually, and use that to check the shape to see if it's if it follows or resembles a bell curve. So we're going to do that in number 1. So we have a survey of 18 high-tech firms, showed the number of days inventory they had on hand. Determine if the data are approximately normally distributed by using a histogram. So in order to do this, we need to make a frequency table. So we need to kind of review how to do that. And they want us to do it for 7 classes. All right, so in order to do a frequency table, there are a few things you need to do. You need to calculate the class width. So the class width. So to calculate the class width, this was back when we did this last year in last semester. But to calculate the last width, you're going to take the range and you're going to divide that by the number of classes. In this case, you want 7 classes. The range is the biggest number minus the smallest number. So you're going to take 158 minus 5 and then divide it by the 7 classes. So in this case, you're going to do the math there. 158 minus 5 divided by 7, and you get about 21.9. And so you're going to round that. You're always going to bump this up, okay? You're never going to bump it down. So you're always going to round up. So in this case, this would be 22. So your class width is 22. And so when we set up our frequency table, we always set it up as class for the first column. Then we have our class boundaries. And then we have our frequency. All right, so to find the class width, you start from, or to find the classes, I mean, you start with your smallest number, which this is already in numerical order, which is very nice for us. So normally we would have to do it in numerical order to make it easier for us, but they already did it for us. So the smallest number is 5. And then you're going to keep going and make your other classes by adding the class width to it. So the class width is 22, so we're going to add 22 to that. And we're going to keep doing that. So and we're going to keep doing this until you have 7 classes. So we have 5, 27, 49, 71, add another 22, 93, 115, so that's 1, 2, 3, 4, 5, 6 classes. We need to do this one more time, and 137. And then you want to get your second number here, because this is an interval of a range of numbers, not just one number. So to get the next number, you do 1 less from the number after it. So this will be 26 since the number after it is 27. Then this will be 48 because the number after it is 49, and so on. And then if you want to get the last number, you notice that the pattern is that you're going to add the class boundaries on either the right side or the left side. So you can also think of it as adding 22 on the right side as well. So we're going to do that here and follow that pattern. So this will be 158. All right, and notice that we have all of our numbers here from 5 through 158. So it doesn't always work out where you have exactly 158. Sometimes you'll get 159, 160, but in this case it worked out nicely. All right, so now we're going to do the class boundaries. So to do the class boundaries, you're going to use the 0.5 rule. Okay, so the 0.5 rule. All right, this is something that we already went over quite a few times, but just to kind of refresh your memory, the 0.5 rule is when you take away 0.5 from the first number and you add 0.5 to the second number. So 0.5 minus 0.5 is 4.5, and then 26 plus 0.5 is 26.5. 27 minus 0.5 is 26.5. 48 plus 0.5 is 48.5, and then you continue the pattern. Okay, I'm going to go ahead and erase this just so I have more room. All right, so then we finished all those numbers. And then now we got to do the frequency. So the frequency is pretty easy. All you got to do is count how many numbers do you have between 5 and 26. So in this case, we have one number. That's it, just one number. How many numbers between 27 and 48? Well, there's 29, there's 34, there's 44, 45. So that's 1, 2, 3, 4. 4 numbers. How many numbers between 49 and 70? 1, 2, and that's it. So 2 numbers. Between 71 and 92. 1, 2, 3, 4, 5. Between 93 and 114. 1, 2, 3. Between 115 and 136. 1, that's it. And then between 137 and 158, that's 2 numbers. All right, so now we got our frequencies. Now we can draw our histogram. So we're going to quickly draw that. When you draw the histogram, you want on the x-axis, you want the class boundaries. Okay, so on the x-axis is your class boundaries. So you have your class boundaries. And then on the y-axis is your frequency. All right, so now, so we need all of our class boundaries. So 4.5 is our first one, and then 26.5, 48.5, 70.5, 92, 114. We need all of them, so all the unique ones. And then the last one is 158.5. Don't forget the last one. There are a total of 2, 4, 6, 8 different ones. All right, so that's all of them. Now we can go ahead and draw the graph. So, we need to do the frequency. So the biggest frequency is 5. We're going to go by ones here. 1, 2, 3, 4, 5. All right, so we want to draw between 4. So between 4.5 and 26.5, we have a frequency of 1. So what you want is your left endpoint at the 4.5, the right endpoint at 26.5. So just like that. And in a histogram, the bars touch. So the next one is 26.5 to 48.5. That's at 4. Okay, this has to be right there. It has to touch. All right, and then 48.5 to 70, we have 2. Next one is 5. 3. 1 and 2. All right, and there's our histogram. All right, so in this case, it kind of looks bell curve. It wants to be a bell curve. This is a little bit higher than it should be, but it's not that, it doesn't obscure it that much. It looks like it wants to be a bell curve. So this is approximately normally distributed. So I'm going to say approximately. So I'm going to say approximately normally distributed. Kind of looks like it wants to do that bell curve shape, you know, like that. So approximately. All right, how do we know for sure that it's actually normally? So real quick, so I needed to make a correction, which is why we skipped. So sometimes you'll get a histogram and you'll wonder like if it's bell curved or not, or bell shaped. So what you want to do, what it really does help, is to do a calculation. And one way to calculate this, whether something is skewed or whether it's bell shaped, is to use what we call the Pearson coefficient of skewness. So this is done by calculating the skewness. So skewness is how far you are from being symmetric, essentially. So the formula for that is this guy. So this is for the Pearson coefficient. The x bar is your average. That's your median or middle number. And that's your sample standard deviation. And then, so the standard deviation is just a measure of the spread of the data. So now, if you calculate this and you get the Pearson coefficient is greater than or equal to 1, then the data is significantly positively skewed. Positively skewed means it's skewed to the right. So it's skewed right. And how that looks like is when it's skewed right, the tail that is longer is on the right side. So you see how that right tail is longer than the left tail? This is skewed right. Skewed left is when the tail on the left side is longer. So it's no longer symmetric. So if the Pearson coefficient is less than or equal to -1, make sure you make that correction. I think in your notes it says 1, it should say -1. Then it's negatively skewed. Or skewed left. If the Pearson coefficient is equal to 0, also make that correction in your notes. I think it said 1. It should say 0. If it's equal to 0 or it's close to 0, then we can conclude that the data is not significantly skewed. So it's probably going to be normally distributed or close to it. All right, so we're going to use the same problem set as number 1 to determine whether it's normal using the Pearson coefficient. All right, so first things first, we got to find the x bar, since that's part of the formula. If you look at the formula, we need x bar, the average. So to find the average, you just add the numbers up and then divide by how many numbers you have. So I'm going to do ... and then I'm going to divide by how many numbers. I have 18 numbers in total. When I do that, I should get, let's see, I should get 79.5, but let me double check. So I get, when I add them together, I get 1431 divided by 18 gives these 79.5. All right, so that's my x bar. Now we need to find our median. Our median is our middle number. So we're gonna, first, normally to find the median, we need to list the numbers in order, which they're already in order for us, so we don't have to worry about that. But normally, if it's not sorted numerically from smallest to biggest, then you can't find the median. All right, so we're gonna start crossing out. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, and 2. So we have two middle numbers, 74 and 81. So in order to find the median, we need to average those two numbers, add them up, divide by 2. When we do that, we get 77.5. I want to make sure that's correct. So yeah, 77.5. So that is our median. Now let's find our standard deviation. So there's a long calculation to do the standard deviation, but we're going to do the shortcut way. We're going to use the calculator to calculate that for us. All right. So and I will show you guys how to do that on the calculator or do it on Excel. Okay. So I'll actually show you on Excel how you would do it. So if you have Microsoft Excel, and in the lab, we'll most likely be doing a lab soon, and I'll show you guys how to do it there as well. All right. So I'm going to go ahead and list out all of the data on Microsoft Excel. And let me make this a little larger. Okay, so I'm going to list out all of the numbers. Okay, so we have 5, so I'm going to type in all the numbers. Okay, so now I got all the numbers, and now what I'm going to do is I'm going to type in equals standard deviation, STDEV dot S, because I want the sample. P stands for, if I said P, that would mean population, but I want sample standard deviation. All right, parentheses, and then I'm going to select all the numbers that I just typed into Excel, and then I'm going to enter, and that will give me my standard deviation. Such a quick way of doing it instead of doing the long way, because the calculation is very tedious. So we got 40.45 as our standard deviation. All right, so now once we do that, we can plug it into the Pearson coefficient formula. So we got 3 times x bar minus median divided by sample standard deviation and get about 0.148. Which is pretty small, so that means that this is very close to 0. So that means since it's close to 0, it's not significantly skewed. Which means that the distribution is approximately normally distributed. Okay, which is kind of verified by our histogram. All right, so now let's go on number 3. We want to determine that the data are approximately normally distributed. So we're going to do the same thing. You know, we're going to use the Pearson coefficient of skewness in order to calculate this, and we're also going to do the histogram. So we're going to combine those together and then use both of those to determine if it's approximately normal or not. All right, so first things first, we need to use the class width. So we're going to do the class width. To do the class width, you need the biggest minus the smallest. So the range divided by the number of classes. So now So now when you do the histogram, you want to choose the number of classes. Okay, so choose the number of classes that's suitable. So the rule of thumb is choose between 5 and 21 classes, no more than 21, no less than 5 generally. So we're going to choose between 5 and 21, so let's choose 6 classes. Let's use 6 classes. So that means our denominator is 6. So let's do our range. Our range is our biggest minus smallest. So we have 162 is our biggest, or 163 is our biggest number, minus 34 is our smallest number, and divide by 6 for our class width. So we get 21.5. Again, we're going to round that up. All right, so that's our number. Okay, so we're going to round up, so it's 22. And then again, we're going to start with, we're going to do our class boundary, shorten that to CB, and then our frequency. All right, so our class. So to do our class, remember, you want to start with your smallest number, which our smallest number in this case is 34. And then we're going to go by our class width, which is 22. So we're going to keep adding by our class width. So 34 plus 22 is 56. And then 78. Then 100. 122. We got so far 5 classes. We need to do this one more time. 144. All right, so then this is going to be one less than that. So 55, 77, 99, 121, 143. And then again, we're going to add 22 to this number to get that last number. So 155 or 165. All right, so there you go. We're good there. Now we can do our class boundary and our frequency. So we're going to use the 0.5 rule. Take away 0.5 from 34, so that's 33.5. Add 0.5 to 55, so we got 55.5. Take away from 56, 55.5, and then 77.5. Take away from 78, and add to 99. All right, remember the reason why we do our class boundaries is because we need them for our histogram so that the bars can overlap. All right, so now the frequency. We need to find how many numbers between 34 and 55. All right, so we're going to go ahead and count them. We have 1 here. And that's it, just one number. So that's 1. Between 56 and 77. So that's 1 here, 2. Between 78 and 99, that's 1 here. And that looks like that's it. Between 100 and 121, 1. And that's it. 122 and 143, 1. 2, 3, 4. 144 and 165. So that's 1. That's everything. That should be everything else. 1, 2, 3, 4, 5, 6, 7. All right. So now we can go ahead and draw the histogram real quick. Oops, let's erase that. Let's do that a little better. So our highest is 77. Let me do that. So our highest is 7. So we're going to do 1, 2, 3, 4, 5, 6, 7. And that's our frequency. And this is our class boundaries. So we have 33.5, 55.5, and so on. Need to make this longer because we also have 165.5. All right, so now we can go ahead and draw it. So the first bar is 1, and it's between these two. The second bar is 2. The third bar, this should be here. So the third bar is 1, another 1, a 4, and then we have a 7. All right, so this is definitely not symmetric. It looks like it's skewed. In fact, it actually looks like it's skewed left, just based on the graph. If you kind of draw it, kind of looks like it's, you know, skewed left, where the longer tail is on the left side. Since it kind of looks like it's skewed left, we're going to go ahead and do the calculation just to be safe. All right, so we're going to quickly do the median and the Pearson coefficient, all that stuff. Okay, so we're going to do the average of this. So I'm not going to show you the work here. You're just going to simply add these guys up. So add them all up, divide by how many numbers you have. In this case, you have how many numbers? 2, 4, 6. So that's 12, 13, 14. So you have 17 numbers here. So 17 numbers. So you have 17. So we're going to add them up, divide by 17. So let's see. We're going to add them up real quick. Okay, so when we add them up, we get 2,163. Then we divide by 17. So we get 127.2. All right, and then now we need to find the standard or the median. So we're going to do this on the side here. So median, so the median is the middle number, okay? So we need to put this in order and then figure out what the middle number is. All right, I'm not going to show you what that is. I'm just going to leave it as an exercise for you guys. So just list these all in order and then find what the middle number is. All right. Okay, so then if you put them in order and then find the middle number, you get 143. So 143 is our middle number. And then our standard deviation, we can go ahead and calculate that. So we're going to do that on Excel. I'm going to type in the data. Okay, so once we type in the data, I'm going to use the command that I showed you guys. So equals stdev.s, standard deviation, and then you highlight your numbers after you put parentheses. And then close the parentheses, enter. And that's our standard deviation, so it's about 39.1-ish. So I'll round it to 39. And then we'll put that in our Pearson coefficient, so it's 3 times x bar minus median divided by standard deviation. And when you do that, you get about negative 1.22. All right, so that means that that's telling us that that's pretty significantly skewed because it's less than negative 1. So therefore is significantly skewed to the left. So that means that this is skewed left. So it's not normal. All right. So there's another way that you can use to determine normality. And one of them is actually to use normal probability paper. So we'll show you how that looks like. So here's the steps for that. So what you need to do is first you need to make a cumulative frequency table. So kind of like the table that we did before, but we're going to have cumulative frequencies instead. You're going to find the cumulative frequencies and then convert them to percents. And then you're going to plot them on the probability paper. All right. If the points when you plot them fall approximately in a straight line, then you can conclude that it's approximately normal. All right, so it's a very interesting property of the probability paper. So let me show you how that looks like. So let's look at number 4. So we want to use the data on blood pressures to determine whether it's normal. All right, so to do that, so they already had the table for us. We just gotta do the cumulative frequencies. All right, so cumulative means you're adding as you go. So you start at 24. And then you continue adding. So 24 plus 62 is 86. 86 plus 72 is 158. 158 plus 26 is 184. 184 plus 12 is 196. 196 plus 4 is 200. And there you go. That's the total, which is 200. All right, that's how you do cumulative frequency. All right, so then now those are our numbers. So now for cumulative percent frequency, we're going to do 24. To find the percent we're going to do 24 divided by our total, and then times by 100. So 24 divided by 200, and then times 100, and that will give us as a percent. And then we keep doing that. So 86 divided by 200 converted to a percent. All right, so we're going to get what each of those numbers are. So this will be 12%. This will be 43%. This will be 79%. That will be 92%. That will be 98%. And that will be 100%. Now we can go ahead and plot those. Okay, so here we have percent. Oops. So we have, this is like our percent. And then this is our class boundaries. All right, so we're going to go ahead and plot that. So 89.5. So for the first number, for 89.5, the value is actually 0. Okay, so the very first number is going to be 0, and then the 104.5 is actually what has the 12%. Okay, since you got to plot it for all of these points individually, so you always start this with 0. Okay, and then this guy, the 104.5, is the one that has the 12%. All right, because since you have two numbers here, you had to pick which one has the 12%, which is going to be the second number. So it'll be 12% for 104. And then for 119.5, okay, so we have the 12% for the 104. The 119 is going to be 43%. Which is around here. The 134 is going to be the 79%. The 149 is 98%. Or I'm sorry, 92%. The 164 is 98%. And the 179.5 is 100%. All right, so then if it looks like it's approximating a line, so in this case, so this looks like it's approximating a line. It's not exact, but it kind of looks like it's approximating a line. Then that means that it's approximately normal. So it does look like it's approximating a line, a straight line, and so therefore so if you do that, it kind of looks like a line. So that means it's approximately normal. All right, and that's it, guys. So those are a couple of different ways to determine normality.